So question for you. Is log base 3 of x the quantity squared equivalent to log base 3 of x, just the argument squared? Is this the same? No, this is not the same. I'm going to disprove it by plugging in a number for the argument. So let's say x is 3. In this scenario, this would be log base 3 of 3 raised to the second versus log base 3 of 3 squared. Now, what's log base 3 of 3? 1. What's 1 squared? 1. What's log base 3 of 3 squared? Shortcut means it is 2. Obviously, 1 is not equivalent to 2, so these are not equivalent. Just want to make sure that we recognize that. All right, let's look at this first example. Let's say I have the quantity of log base 3 of x, that quantity squared, minus 4 times log base 3 of x minus 12 equals 0. And I want us to solve.
Can we add 12 on both sides?
No, you can factor them.
Oh, yeah, you can.
Factor them.
Very good. Dravid just said we can factor this. How did Dravid know we can factor this? We have a quantity squared, and that same quantity, right? Log 3 of x raised to the first. So what I'm going to do is I'm going to use substitution. I'm going to let m equal log base 3 of x. So now we're going to have m squared minus 4m minus 12 equals 0. Do we know how to solve this? We surely should. Easy factoring. We are m minus 6, m plus 2. And then we go on and solve. We get m is equal to 6 and m is equal to negative 2. But this is not the answer. Why is this not the answer? We have to first substitute back in. So now, remember, m is not what we were solving for. We were trying to solve for x. So this brings us to log base 3 of x equals 6. And log base 3 of x equals negative 2. Remember, what is this? Log base answer exponent, right? Log base answer exponent. So what is this really saying? 3 to the 6th power equals x. Remember, if I said if the exponents 5 or larger, you don't have to multiply. So this is an answer. And this one is saying 3 to the negative 2nd power is
729.
x. So x is 1/9. Where are you getting 7/29?
I just did it in my head.
No, he's doing the other one. He's
I was
doing 3 to
just
the 6.
bored. I was just bored.
He's doing 3 to the 6.
Y'all can't be, are you all talking to me or to each other?
No. 729 is 3 to the 6.
Yeah. 9 times 9 times.
Oh, you were multiplying 3 to the 6th. That's fine.
Right, John?
Why would you do that?
I was bored.
Bro,
You was
it's
bored,
Hey.
so you did
I finished the
3 to
problem.
6.
I finished the problem, guys.
All right, next one.
Yes.
So here we're going to have 7 raised to the 2x minus 7 raised to the x equals 20.
So you could do that again.
So once again, what can we do?
Set a log.
factor.
We can factor this. We have some quantity raised to the 2x, the same quantity raised to the x. So what I'm going to do is I'm going to let m equal 7 to the x. So now we are m squared minus m. I'm bringing that 20 over, so minus 20 equals 0. So now we are m minus 5, m plus 1 equals 0. M equals 5, m equals negative 1. Oh, no, 4. Sorry, guys. Now let's plug back in because we weren't solving for m. So we said m was 7 to the x. So this is saying 7 to the x is 5, and then 7 to the x equals negative 4. Is there any exponent that could make a number negative? No. So what do we realize right away? This rejects. So now we're just dealing with the left side. So now I need to solve for x. How do I solve for x? I need to get it out of the exponent. How do I get it out of the exponent? Log. So we're x log 7 equals log 5. What are we going to do? Divide by log 7. So in your calculator, you are log 5, division sign, log 7. I would rather you overuse parentheses than not use them and get the wrong answer.
I got 0.827.
0.827, good.
How much you get?
Oh, I got.
What'd you get?
Yes.
Oh, I switched the numbers. My bad.
Guys, every time I breathe for a second, you cannot start talking because I can't hear the questions coming to me. Navia.
If like 7 was like negative, would you have still rejected that answer? Because if it was like an odd exponent.
Well, we never, we say it one more time. So you're saying if our base was negative, we never want our base to be negative in log equations because remember, because then if you raise it to a fractional exponent, then it's imaginary. So we don't want that. Okay, can we keep going? Yes.
How many decimals do you round to?
I will have to tell you on the test. Right now I'm just doing 3. Okay, guys, next one. 3 to the x plus 3 raised to the negative x all over 2 equals 2. My first step in this is I'm going to get rid of that denominator of 2 by multiplying by 2 on both sides. When I multiply by 2 on both sides, I get 3 to the x plus 3 to the negative x equals 4. So now I'm going to let m equal 3 to the x. If m is equal to 3 to the x, do we agree this is going to be m plus 1 over m good equals 4? What do you think I'm going to do with that denominator of m now? I'm going to eliminate that denominator, so I'm going to multiply everything by m. When I multiply everything by m, I get m squared plus 1 equals 4m. Right, because those m's cancel. Now this is something that looks like maybe can be factorable, so I'm going to put it in the format. M squared minus 4m plus 1 equals 0. I cannot factor this. There are no factors of 1 that will ever add to a negative 4. So that doesn't mean we can't solve. What do we have to use? The quadratic. So m will equal negative b, so that's a positive 4, plus or minus the root of b squared, which is 16, minus 4 times a, which is 1, times c, which is 1, all over 2 times 1. Okay, now we simplify. M is equal to 4 plus or minus the root of 16 minus 4 all over 2. So m is equal to 4 plus or minus the root of 12 over 2. Some of you forgot basics. You have to simplify radicals. You cannot leave that root 12 as root 12. So then we're going to have 2 root 3. Root 12 is 2 root 3 all over 2. I'm still not done. Why not? Substitution. No, we're still not done simplifying.
Divide by take out the 2.
Yeah, we can take out that 2. So then we're going to have m is equal to 2 plus or minus root 3. Now what are we going to do?
Substitution.
Substitute back. Remember, my m is not m. My m is really 3 to the x equals 2 plus root 3. And then my other equation is 3 to the x equals 2 minus root 3. Do we agree log both sides?
Yeah.
All right, so now we are x log 3 equals log, in parentheses, 2 plus root 3. I need to solve for x, so I'm just going to divide by log 3 on both sides. So x equals log of 2 plus root 3 over log 3. Which is gonna, you guys practice this in your calculator. So it's approximately 1.199. And what do you think the other one's gonna be? X equals log, good, log of 2 minus root 3 over log 3. And that should give you approximately negative 1.199. Is it okay to have a negative exponent? Absolutely. It's absolutely okay to have a negative exponent. I have one more and then, or no, 2 more and then we're done. All right, ready for the next one? Yes, no, maybe so.
Never.
Okay, next one. Log of log x equals 0.57. Right, so I'm looking at this. There's no shortcut here to simplify down, right? It's not like, you know, ln of e, right? It's not any of that. So what I'm going to do is I want to change to exponential. Right, how do I change to exponential? Remember, it's log base answer equals exponent. Do we agree? Well, when there's no base written, what's our base? 10. So what is this saying? 10 raised to the 0.57 equals log x. Now, anytime we have the base of 10 raised to an exponent, what is that? That's an antilog. Exactly. This is an antilog. So, look at here. Do we agree? This is, well, all right, I'm going to keep it 2 ways because we still need calculator ready. So I'm going to write it 2 ways. I'm going to keep it left side is calc ready. And right side is antilog. Are we okay with that? All right. So now 10 raised to the 0.57 is going to be the antilog. And remember, with the antilog, it's the inverse, right? So the what's next to it is the exponent. So antilog 0.57 equals log x. So I just changed the left side. Okay, so now let's work on the left side now. So now on the left side, once again, I'm going to change to exponential. Well, no, because we still have another log. So it's going to be like stacked exponential. Okay, so now we're going to change to exponential again. When I change this to exponential, remember it's log base answer equals exponent. Right, so now what is this? 10 raised to the 0.57 equals x. This is our calculator ready form. Do you want me to show you how to put this into the calculator?
Why is it just x not x to the 10 because it's log base 10?
Say it one more time.
Why isn't it x to the 10 if it's base 10? Wait, or is it because you take... Oh, I think it's... Oh yeah, that would... I read it like weirdly, so I thought it was like two separate things. But...
You're okay?
Yeah.
Okay. All right, can we now go to the anti-log side? So this is your calculator ready. That's what I would accept for calculator ready. But now let's look at the anti-log side. So right now we need to solve for x. We need to get rid of the log. Do you guys remember what will cancel out with a log? An anti-log. So what we can do here is multiply by the anti-log of both sides. So now you have a double anti-log. So this is anti-log, and then open your parentheses, another anti-log, 0.5, oh, actually I don't need those parentheses, 0.57 equals x. So this is your anti-log format, that's your calculator ready format. And if you plug this into your calculator, you are approximately 5,192.210 if we're going 3 decimal places. Are you ready for the last problem?
Let me just put it into my calculator.
Oh, you want to make sure? Sure. Try putting it into your calculator.
So 10 to the...
How do you get the first step of the answer?
Which one? This side? Okay. So anytime you have 10 raised to an exponent, that is an anti-log. I know it's just 10 raised to an exponent, but we make you write it as an anti-log. So anytime you see 10 raised to an exponent, we write it as an anti-log. And with the anti-log, the exponent is now in the position where the argument used to be.
I just put the anti-log on both sides, so it's not x. Anti-log of 10 to the 0.
But then 10 to the, that's exactly the right thing, but then 10 to the raised to that exponent is another anti-log. So that's why you get the double anti-log. Do you see what I'm saying? Anytime you have 10 raised to an exponent, it's an anti-log.
Do the anti-logs cancel? Or do you just love the anti-log of anti-log?
An anti-log cancels a regular log.
Oh, they don't cancel each other.
No. Can we go on? Did you guys all get this when you plugged in?
Yeah.
Okay, last problem for today.
Is it bad?
It's all right. Hold on, no. That's wrong, hold on. Only the 7, only on the 7.5 is raised to the negative 0.06x. Yeah, that's the problem. So only the 7.5 has that exponent, guys. Only the 7.5 has that exponent. All right, so where do you think I'm going to tell you to start? Multiply both sides by 9. So we got 72 equals 2 plus 7.5 raised to the negative 0.06x. What do you think I'm going to tell you to get rid of next? The 2. So now we're going to have 70 is equal to 7.5 raised to the negative 0.06x. All right, so we've done enough prep work, right? Now we need to get that variable outside of the exponent. So what am I going to do? Log both sides. So we have log 70 equals negative 0.06x log 7.5. This isn't actually so bad, right? Isn't this all multiplication?
Yeah.
So what am I going to do? I'm going to divide by negative 0.06 log 7.5 to isolate that x. And negative 0.06 log 7.5. So those cancel, those cancel. This is your calculator ready form. And what did we get? Approximately negative 35.142.
I got negative 3.5.
Is it 3.5? Did I write it down wrong?
What?
Did you guys put parentheses around the bottom?
No, I got negative 26.
Yeah, I got negative 26.
Oh boy. Okay.
I got negative 3.5.
All right, all right.
That's right.
I think it's time to go to the calculator.
You got that?
I got
Okay.